So we're on page 4 of the chapter 9 practice test. We're going to be skipping number 20. Number 19, this radical was supposed to go over all of it. It looks like it didn't. A printing of it. Alright, number 15 says, how many real roots does each of the following have? So in other words, could this 18.2 be positive or negative and we get the same answer? If you square positive 18.2, or you square negative 18.2, do you get the same answer? I hope you know this, but I'll show it to you just in case you don't. 18.2, if we square it, and then negative 18.2, if we square it, we get the same thing. So this or this can be the root. So this has 2 real roots. In summary, anytime this is even, 2, 4, 6, 8, you can have a positive or a negative, and you'll still end up with the positive answer. Let's look at part B. Negative 18.2 to the 5th. Let's see what that is. Negative 18.2 to the 5th power. Now, what happens if I do positive 18.2 to the 5th power? I get a different answer. I don't get a negative. So this only has one real root, only the negative 18.2. So this has one real root. So in summary, if the exponent's odd, then you only have one root. All right, let's go to number 16. Number 16 asks us for the value of 1/81 to the negative 3/4 power. So in order to make that exponent positive, I'm going to cross the line and change the sign. I'm going to put the 81 on top and the 1 on the bottom, which means I can just have 81. And now I can make it to the positive 3/4 power. So the 4th root of 81, which I know is 3, and then I'm going to take 3 and cube it, and I get 27. Just want to clarify, you can only change exponents from positive to negative by switching the line. A lot of people think, now that we have this exponent rule, that negative 1/5 can be positive 5. It's not. We can't move the 5 to the top. This is not a numbers rule, it's an exponent rule. We were able to cross the line and change the sign of the exponent, not the sign of the number, the sign of the exponent. All right, let's look at number 17. A to the 3/4 divided by a to the 2/5. Well, division means I subtract my exponents, just like if we had a to the 7th over a to the 3rd, we would have a to the 4th. Well, here I'm just giving you fractions instead. So we have a to the 3/4 minus 2/5. Common base, we subtract our exponents. Well, I need my exponents to have a common denominator, and I know my common denominator is going to be 20. 3/4, when I change it to 20ths, is 15/20. 2/5, when I change it to 20ths, is 8/20. So I get a to the 7/20. Right, number 18. Rewrite in radical form. Okay. First thing I need to do is power to a power. So 3 to the 7 times 17 divided by 9. Let's see, 17 times 7, 9, carry a 4, 119. So this is 3 to the 119 over 9. So it's the 9th root of 3 raised to the 119th power. You could also write it as the 9th root of 3 to the 119th power, like that. But power over root. All right, and lastly, number 19. Write using exponents. So I have 9 to the 1/7, x to the 3/7 power over root, y to the 2/7. And that's it for page 4.